Hello everyone. In this video we're going to prove this trigonometric identity. Definitely looks like there is more to work with on the left side, so we'll start on the left side and work our way to the right side. So we'll go ahead and just reproduce the left side without any modification. Minus cosine x minus 1 over cosine x plus 1. All right, so as we have discussed in other videos, in these situations, especially when you have conjugates in these denominators, strategy is to go ahead and combine the fractions, especially when we can see that we only want to end up with one term. So the first thing we'll want to do is somehow get out of having two terms and have one term. So that's another reason you'll want to combine those two fractions. So we notice on the denominator we're going to have cosine x minus 1 over times quantity cosine x plus 1. And now, of course, in order to make the first denominator like the common denominator, we're going to have to multiply it by cosine x plus 1, which of course means that we have to do the same on the top. And to make the second denominator like the common denominator, we're going to have to multiply by cosine x minus 1. So that's what we will do now. And we'll want to do the same on the top. Make sure that you are parenthesizing the expressions in the way that we are to make sure the proper distributions occur. So now for the first numerator, we now have cosine. Let me go ahead and go back to the other color. So we have cosine x plus 1 squared minus quantity cosine x minus 1 squared. So now we're going to have to recall these identities from algebra, which we had f plus l, quantity f plus l squared equals f squared plus 2fl plus l squared. That was the identity for the sum being squared. And we had one for the square of a difference, f minus l squared, which is similar, but the middle term becomes negative. All right, so applying the first identity here, we're going to get cosine squared x plus 2 cosine x plus 1 minus quantity. Super important to have that parentheses because the negative is going to have to get distributed into the whole expression. So now we're going to apply the second algebraic identity on this product. So we end up with cosine squared x minus 2 cosine x plus 1. And all of that is going to be over this expression, which I realize from another algebraic identity for the product of two conjugates, which is going to give me f squared minus l squared. So we see that this is going to turn into cosine squared x minus 1. So now we go ahead and distribute that negative. So we have cosine squared x plus 2 cosine x plus 1 minus cosine squared x plus 2 cosine x and then minus 1 all over cosine squared x minus 1. Now I notice on the top that we can cancel the cosine squared x terms and we can cancel the 1s. So the 1 and the negative 1. So now we end up with 4 cosine x, because these two terms can be combined, over, now again I see cosine squared and 1, that should remind us of the trigonometric identity, which was called the Pythagorean identity, which says sine squared x plus cosine squared x equals 1. So if I keep the cosine squared x here and I move the sine squared x to the right side while bringing the 1 to the left side, I end up with cosine squared x minus 1 equals negative sine squared x. Notice that we moved sine squared to the right side and we moved the 1 to the left side so that we can obtain the expression of interest. So we can replace the cosine squared x minus 1 with negative sine squared x. Now, keeping the target in mind, we can see we're getting very close. We have one term, we have the negative sign, we have the 4, everything looks good, so we need to work on this part to see if we can make it into that. And of course, we realize that we can go ahead and write this as negative 4 cosine x over sine x times 1 over sine x. Notice the numerator is negative 4 times cosine x times 1, which is negative 4 cosine x, and the denominator is sine x times sine x, which is sine squared x. So they're equivalent expressions. So now we can say that's equal to negative 4 cotangent x cosecant x, which is the result we were hoping for. And now the identity has been verified, so we can go ahead and say QED. All right, so that's how you would approach a problem like that. Be safe until our next video.